Okay, in this video I'm going to show you the main components of a very simple brushless motor, direct drive, variable speed, potter's wheel. The good thing is it doesn't need any sophisticated tools apart from a saw, screwdriver, jigsaw to cut out the circular turntable, and all parts should be readily available. I attempted to use the metal frame from the hoverboard, but actually it was more difficult to locate those and keep them vertical than it was to use a wooden bracket. So you only need the motor, the wheel, the square bracket, the little square bracket with 4 holes that will be used in the wooden bracket, and you can discard all the metal plate frame. This shows the electronic speed controller. It's 36 volts, brushless, and 250 watt, and it comes with multi-pin connectors. There's a drip tray needed, so this is just a plastic storage box, and the whole assembly, the wheel assembly, sits inside this and can be lifted out to clean and carry away the slops from the pottery. You'll need a piece of MDF or plywood, about 18mm thick, about 300mm square in the case of this box I'm using. And you'll need to fabricate a wooden bracket. This one's from 2 pieces of 90mm by 36mm CLS wood, 240mm long, screwed together to create a thicker block, and there's a groove sawed in one edge, which is the mounting groove for the motor. It's about 10mm wide and 3mm deep, and the curved edge of the motor spindle sits in there, and the square edge of the bracket engages with the square edge of the shaft. These are 2 different types of hoverboard motor, same dimensions. This one's 36 volts, 250 watts, and that's 200 watts, 24 volts. So just check which ones. This low voltage one runs faster than the higher voltage one on the 36 volt speed controller. So the wires that come are short, but you need to extend them. So here I've braided up some single strands, 8 single strands into a braid, and I've moved the 2 connectors to the end of that and soldered the wires together. So we have a 5-pin hall connector and a 3-pin drive for the motor. And the turntable is simply silicone glued onto the wheel and then screwed into the rubber directly through. It's easier to do that once you've built the wheel rather than before. Then you can centre the turntable before you screw it down. This is a 36 volt DC switched power supply. They're about £20, £30 perhaps, and this is the brushless 36 volt speed controller, about £10. That's the main 3 wires for the brushless motor. That's the 5-wire hall output or input. This is the power supply. There's 2 red wires joined because you don't have a key, switch on off key here, you just have it on all the time, it's plugged in. And that's the 3-wire for the throttle. These 2 wires just reverse the rotation if you engage them, and then everything else, brakes etc., we don't use. So this shows the mounting bracket with dimensions there on the MDF base, and there are 4 little feet to keep the base above the slops in the drip tray. You can see the groove a bit clearer there. That needs to be absolutely square when you cut it. Doesn't really matter whether it's curved or square shape, but it needs to be 90 degrees so that the wheel sits vertically upright. That's held down by 2 bolts 2 screws, wood screws, and then from underneath 4 wood screws hold the whole lot together. So these are wood coach bolts. They've just got a hexagon head rather than a screw to give it a little bit more force to tighten it, although it doesn't need that much. It seems to be pretty solid. There's the flat face, which will engage with the metal bracket, and the curved edge sits in the groove. Where the wires were joined, they were soldered and taped up with PVC tape. It's a good idea to keep those high so any water that drops on them rolls downwards rather than have them downwards and therefore potentially lying in water. There isn't much water end up on that wire. Most of it splashes to the edge of the box of the drip tray. So all the controller, power supply sit outside of the box, and it's only that 36 volt motor, or 24 volt motor in this case, that's inside. I tried various types of potentiometers and other speed controllers. This is the cheapest way to do it. It's a £5 twist grip for an e-bike. I've adapted it a bit. You need to saw the side off of it to get it open, and once open you can see the magnets that work with the Hall sensor are set to operate 0 to 100% over about 90 degrees movement, but we need about 30 degrees movement for a foot pedal, so I've simply moved one of the magnets about 10 millimeters, and I've created a 10mm wide end stop to stop it rotating any more than it needs to, and that gives 0 to 100% output over a much shorter range of movement, which suits your foot in a sitting position. And then I've just supported the free end with a bit of tube, 22mm tube, that spreads the load, so when you put your foot on it's supported at both ends. So here's the system, the power supply, the controller and the foot pedal, and then the wheel inside the drip tray. I'm standing up so I haven't got much control over the speed, but you can see I can get it going very slowly and various speeds in between, up to over 300 RPM full speed. The electrics here are exposed for ease of seeing what's happening, but they go inside a waterproof box just tied in with cable ties, and the bunch of unused wires that I bound up with black tape contains a multi-connector for the 3-speed function. So if you want to reduce the maximum speed, you can just short out 2 pins on that 3-pin multi-connector. So here's just a quick demo. Finally, you can set it by hand to whatever speed you want and it holds, and obviously use the foot pedal. And finally, a quick demo of how transportable and light the unit is. You can just switch it off, pick it up and put it in a cupboard. So thanks for watching, and good luck if you have a go.